Imagine spending your entire workday doing nothing but chewing. For early hominids surviving on raw plants and meat, that was the exhausting reality. Foraging for survival presented a severe mechanical problem. Unprocessed roots and raw animal tissue contain tough fibers and dense proteins that require relentless jaw power to physically break apart in the mouth. This scale graphic compares the physical effort required to chew raw food against the energy gained from it. It illustrates a biological trap known as a caloric deficit, where the calories a hominid burned by chewing and digesting barely outpaced the calories the food provided. Early human ancestors were stuck in a grueling loop. They had to spend up to 8 hours every single day grinding down raw food with their teeth just to maintain their baseline survival. Then, the environment offered a sudden, violent solution. A random lightning strike ignites a fast-moving wildfire across the dry savanna. After the smoke clears, a foraging hominid wandering through the hot ash stumbles across a fallen animal or a starchy tuber that has been roasted by the natural blaze. They take a cautious bite and experience something new. The food yields. The dense fibers are tender, sweet, and require almost no effort to chew. Over time, our ancestors learned to recreate this accidental process on purpose. But how did this single culinary discovery physically restructure the hominid body? Cooking essentially acts as a form of pre-digestion. By applying heat to food before eating it, early humans used fire to break down complex proteins and soften stiff plant fibers outside of their own bodies. The high heat also acted as an immediate biological purifier. It killed off dangerous parasites and bacteria, turning heavily scavenged, risky meat into a reliable source of calories. This brings us to evolutionary biologist Richard Wrangham. He championed the cooking hypothesis, arguing that this newfound dietary efficiency triggered a significant anatomical reaction. This side-by-side silhouette compares human anatomy over time to show a remarkable trade-off. Because humans no longer needed large, energy-intensive intestinal tracts to break down raw food, our guts physically shrunk. The diagram shows where that saved biological energy was redirected, upward. The calories previously spent on heavy digestion were now fueling the expansion of our calorie-hungry brains. The chronology reveals a distinction. We didn't figure out fire because we were smart. Our species grew these complex brains precisely because we started cooking our dinner. Tracing the exact origin of fire control is difficult. How do researchers prove a fire burned out hundreds of thousands of years ago? Archaeologists isolate specific physical evidence buried in the sediment. They look for microscopic, concentrated layers of ancient charcoal and fragments of fossilized animal bone that show clear chemical signatures of high-temperature burning. This top-down view of an ancient stone structure shows a clearly defined central hearth. These structured sites prove that early humans were routinely controlling fire between 300,000 and 1 million years ago. Look at these 4 fossilized Homo erectus skulls. Their teeth and jaws are already significantly smaller than their predecessors. This anatomical shift suggests that fire control may stretch back nearly 2 million years, though the exact dates remain a subject of debate. While the exact millennial timestamp remains buried in the ash, the fossil record yields a clear sequence. Our physical evolution moves in strict alignment with the taming of the flame. The end of the 8-hour chewing marathon provided early humans with a surplus of something their ancestors lacked: free time. The controlled fire became a physical anchor in the landscape. Instead of constantly wandering the savanna to forage, communities stayed in one place and gathered around a central, glowing hearth. Sitting face to face and sharing soft, energy-dense meals safely in the dark required coordination. It fostered vocal communication, mutual protection, and the establishment of group norms. Protected by the light of the flames, these early humans utilized their new surplus of time to engage in complex social bonding and, eventually, storytelling. Roasting a tough root over an open flame provided the excess calories required to wire our brains and the localized safety needed to culturally bind us together into a society, which is a vast improvement over grinding on raw bark all afternoon. To keep feeding your calorie-hungry brain, make sure to hit subscribe.